local forecast, accurate and dependable from the Weather Channel.
Pikes Peak. Over the years, man has challenged her in many ways, and many times man has lost. She has claimed lives before, but perhaps in no case so bizarre as the one case in which her complicity is merely suspected. On March 3rd, 1991, United Airlines Flight 585 was making what appeared to be a normal approach to Colorado Springs.
The conditions at the time of the crash were clear skies. Visibility was unlimited. Matter of fact, at the airport, Colorado Springs Airport, the visibility was reported as 100 miles. The airplane was a Boeing 737-200 model. Was en route from Denver, Colorado to Colorado Springs, and it was making an approach to the Colorado Springs Airport.
What happened then is bizarre almost beyond imagination. The National Transportation Safety Board, in an effort to understand the accident, created this computer reconstruction of the events that followed, based on the readings from United 585's flight data recorder. The transcript from the cockpit voice recorder scrolls to the left of your screen. Minutes before the crash, everything appears to be normal. The flight has been uneventful, the weather is clear, the crew is alert. As the aircraft nears the airport, about 4 miles from Pikes Peak, we get the first indication that something is not right. One word from the co-pilot: wow. Suddenly, and with no further warning, the plane rolls to the left, then pitches to the right, and in just 9 seconds dives into the desert at more than 230 miles per hour. Desperate seconds, from the first indication of trouble to oblivion. 25 died. Not a piece of the aircraft was left intact. What could have caused such a horrifying and unexpected event? Once again, as too many times in the past, the NTSB set about to find out what happened and why. When the National Transportation Safety Board investigates a crash, they do so with a thoroughness that is mind-numbing in its attention to detail. Pieces of the downed aircraft are brought here to the NTSB's investigative laboratory in Washington, D.C. Here, the aircraft is studied. Its flight data recorder is read to determine the exact position of flaps and struts. The metal of the plane is tested to find stress fractures, flaws in the metallurgy, parts that were improperly installed, anything that is not as it should be.
Okay, this one's a little bit better. I'm happy.
Unfortunately, I can't give you any magnification of this unit here, but you can see the holes that are there.
Parts are even placed under a scanning electron microscope to search for flaws. Answers to questions involving one of man's most complex creations, a bundle of steel, wires, and hydraulic fluids, bigger than a house, can be answered by looking at it on the near molecular level.
I've already taken the tape out.
Or at least sometimes they can be answered. For as rigorous as the investigation standards are, after months of looking at what remained of United 585, the NTSB came to a conclusion they had reached only once before in their history.
The National Transportation Safety Board, after an exhaustive investigative effort, could not identify conclusive evidence to explain the loss of United Airlines Flight 585.
Cause unknown, the official finding. But many believe the answer may lie in a little-known phenomenon, a type of wind pattern that occurs near certain mountains, mountains such as Pikes Peak, a type of wind pattern called a rotor. At the University of Colorado, students studying with Dr. Al Bedard learn how elements flow.
At one point, NTSB requested some resources in terms of finding out the types of flows that can happen in the atmosphere. So we were acting as resources to the Transportation Safety Board in any way that we could help them.
Bedard works in what's called a fluid modeling lab. The tests conducted here help us understand the flow not just of water, but of air.
Actually, flow in a stream is a very good analog of the kinds of flows that happen in the atmosphere. If you take a look at a stream, you'll see flows eddying around rocks. They may produce even cyclic eddies that are very organized. At times it's quite turbulent, other times it's very organized and gentle, with organized motions in it. Very similar things happen in the atmosphere, but the atmosphere is even far more complex than stream flows. I think unsteady flow over a mountain produces a vortex sheet which could roll up. We've been modeling this in the laboratory. Steve Storms is a project currently in progress to understand and apply these to real atmospheric terrain.
To test his theories, Dr. Bedard sets up simulated mountains in his fluid modeling tank. Water flow through the tank simulates the flow of air over a mountain range or a single obstacle, such as Pikes Peak. Dye released into the water allows us to actually see the flow pattern. As the water surges over the modeled mountain, it begins an obvious rolling motion, almost comparable to a horizontal tornado. But is the same effect created in the real world? Here is a time-lapse film of clouds over the Rocky Mountain foothills. Sped up, the rolling motion is seen clearly. At the Boeing Corporation in Seattle, scientists recreated the atmosphere that existed near Colorado Springs the day of the crash of United 585. Pilots were sent to face the rotors in flight simulators at Boeing's training facility. By skimming the top of each yellow post in their simulated plane, the pilots follow the exact path of the doomed United Airlines Flight 585. Watch as the rotor rolls in from the left. Even when they knew the rotor was coming, again and again, they failed to navigate it successfully. Those who survived did so only after a gut-wrenching recovery. Dr. Bedard is careful to note that rotors are only speculated as the cause of the crash of United 585.
I don't know personally what caused the crash, and I certainly concur with the NTSB finding that they did not find a probable cause, because it's one of these things where you're trying to recreate possibly very concentrated flow field of very short duration that was very difficult to predict, detect, or analyze even after the fact. So that is the challenge, I think, to define the potential hazards in an area like Colorado Springs, Anchorage, Alaska. Other airports are similarly located, and there's a need to understand the potential hazards in these areas.
NCAR's Bill Mahoney echoes those concerns.
Mountain-induced turbulence and rotors are a very big hazard because they have the possibility of flipping an airplane, much like the crash in Colorado Springs. That one of the potential hazards in that particular crash was a rotor. But the problem is being investigated.
One answer to the problem of rotors may be the new laser radar, or LiDAR.
Okay, let's roll out now. Good hitting. We got a radar alert and a LiDAR alert.
As we saw earlier, NASA's Roland Bowles and his associates used LiDAR to identify clear air turbulence during their flights into wind shear.
Next year, there's going to be a field study in which we take these LiDAR systems, these laser radars, and start looking for the phenomenon and try to characterize it from a scientific point of view. Once you understand what causes the rotors to occur, how often they occur, then we can get a better picture of how much of a hazard it truly is and where the hazard may exist around the country. And then at that point, we'll move forward, if need be, and develop systems that may help detect those. A lot of the research that is done on aviation hazards has been completed because there has been a tragedy at some point in time. The microbursts were really seen as an aviation hazard in somewhere around 1978. The first step with microbursts was do the research. Do they exist physically? How often do they exist? And what can we do about them if we determine they are a hazard for aviation? We're at about the same point now with rotors as we were in 1978 with wind shear. So we're probably about 5 to 10 years away from having all of the answers and to have actual detection systems in place to warn the aviation community about those events.
There is no doubt our fear of flying is far out of proportion to its actual danger. There's just something unnatural about tons of metal, not to mention flesh and bone, hurtling through the sky at 500 miles per hour. Most take it in stride, but for some, our palms sweat, our jaws tighten, our hearts race. And from time to time, our fears are reinforced. Those whose fear overcomes logic know that research progresses. With new materials and new manufacturing techniques, aircraft grow faster, surer, safer. With the latest in training technology, pilots and crew are better equipped and more responsive. After some 90 years of flight, only the human psyche remains the same. The psyche that seems to demand we look at such a strange and wondrous feat as flying with an unfounded but understandable fear. Perhaps we'll never eliminate that fear, but step by step, we're reducing the danger. Someday, perhaps weather-related air disasters will be a footnote to the history of aviation, along with barnstorming biplanes and white silk scarves.